Good day to you all. And today we are coming to the third session of statistical analysis related discussion. And today is the last session of my lecture series. And previously, within two sessions, we discussed about your data collection tools, and then the last time we discussed about your pilot data analysis. That means you are now in the position with collecting all your related data with respect with your target audience. Now today we discuss about how to do your main data analysis. And moving that, first of all, we need to make sure that your measurement items or your questionnaire or your collected data are valid and reliable. So we have to perform the fact analysis, that means confirmatory fact analysis. And based on that results, we have to check your validity test. That means we need to check with the convergent validity and discriminant validity. Then we have to consider about your reliability test. Then after make sure that your data set is valid and reliable, then we can move in with your main data analysis like regression analysis. And finally, I will discuss about how to do some mean comparison test. So because some students are like to do with the gender related result analysis, that means result comparison, or you might have different income level target audience, might have a different education level target audience. So we can make sure that there are any some differences among those various groups. So I will discuss it at last. So moving with this, I will first of all, let's look at how to make sure that your collected data have adequate validity and reliability standards. So therefore, I'm using some example data sets. So based on that, you can perform your own collected data. Now, this is the data set example I'm going to use in order to show you how to do the fact analysis, right? So before moving that, I will explain you a little bit about what is a validity and reliability. I know that you already aware about those factors. So validity means we have to make sure that whether you collected the measurement item, your collected data actually measured what you want to measure. So that is the meaning of validity. And reliability means we want to make sure that whether your respondents responds with a consistent manner. So that's the difference between validity and reliability. So we have several tests can be performed to make sure the validity and reliability. So in order to check first whether your measurement items are valid, right? Remember that before checking the reliability, we have to make sure that your measurement items are valid, right? That's why we first check the validity and then move into the reliability test, right? So therefore, don't test the reliability first until you make sure that your measurement items are valid, right? So now we are moving to the validity test. Right. So first of all, I will explain a little bit about this data set. So this data set is based on there are three variables, two independent variable and one dependent variable. Right. Resource and capabilities are independent variables and performance is a dependent variable. So in order to measure the resource variable, there are 6 measurement items, and to capability, there are 5 measurement items. And for performance, there are 5 measurement items. All are measuring in the scale type, and you can see their measurement values, right? So it's 1 to 7 scale, right? So this is the data set we have collected. Now you can see there are around 172 responses in this data set. Right. Now, first of all, we need to make sure that our data set is valid, right? In order to test the validity, first of all, we have to run the confirmatory factor analysis. So confirmatory factor analysis means, I told you that there are 6, 5, 11, and again, there are 16 measurement items to measure the 3 variables, right? To measure these 3 factors, we have 16 indicators. Okay, so we want to make sure that whether these 16 indicators are actually measuring these 3 factors. That is what we are measuring through factor analysis. Okay, now this is the path. Okay, now go to analyze, right? Then come into the dimension reduction. In here, you can see the factor. Analyze, dimension reduction, and select factor. Now in here, you are again one window, one box open. So here, what we are doing is, we have 16 items as I mentioned you, right? Now we want to make sure that these 16 items actually measuring our 3 main variables like resource, capability, and performance. First, you have to select all these 16 items, right? Your measurement item, all the measurement items in your questionnaire. In my case, I have 16 measurement items. So select them and put them into the variable box. Okay, put them into the variable box. Then go to the descriptive command. Okay, under the descriptive command, you can see there is a correlation matrix called KMO and Bartle test. Right, so this is we call Kesame, Klein, and Bartle test. Right, I will explain you with the standard when we are coming to the output window. Okay, then next you have to go with the rotation. Right, under the rotation, we click the ProMax rotation. Okay, you have to click ProMax rotation. The rotation, this means those measurement items, they try to rotate through these 3 factors, right? Not the 3 factors, several factors. And we want to make sure that whether our 16 items are rotated with our 3 identified factors, right? I will explain you a little bit later when we come into the output window. Then continue. And then please go to the these options. Okay, go to this option command. And in here, we want to make sure that our measurement items are loaded properly to our factors. Right? We need to make sure that our 16 measurement items are loaded into that particular 3 factors in an effective way. So normally our factor loadings, that means one measurement item's weight should be at least greater than 0.3. So that is a standard, right? So it should be greater than 0.3. That means at least one item has to be weight more than 0.3. So therefore, in here, the suppressed small coefficient mean we ask factor analysis test to remove all unnecessary loadings which are less than 0.3. Right? That's why we put it the absolute value called 0.3. Right? Then the test automatically remove all the loadings which you have below 0.3. That's why we have to put this command. Okay. Then continue. Where I got it in the options. Then suppress small coefficient, tick it. Then this absolute value below window open. Under that you have to put the mark called 0.3. Right? Then press OK. Right. Now you can see the result. Okay. Now you can see the result. Now what we can see. I will come to that KMO later. Okay. First, you have to make sure your attention, right, to this total variance explain. Right. Please put your attention to this total variance explain. Now what you can see. Okay, now what you can see. So under this, right, I put the marks and come into that. Under this, you can see these 16 factors are loaded into 4 factors. 16 measurement items are loaded into 4 factors. Right? Actually, how many factors we have? We have 3 factors. Right? Resources, capabilities, and performance. But unfortunately, these our 16 measurement items in the factor analysis test, it's loaded in, they are loaded into 4 items. So then it is completely wrong because we need to have only 3 factors. Then after looking at this one, now you can see those 16 factors are measuring 61 the 61 variations in your measurement items. Okay, that means that is good. That standard is good. But it's loaded into 4 factors. That's our issue. Then go to this pattern matrix. Okay, then go to this pattern matrix. Now what you can see. Okay, now this pattern matrix indicate we have 4 factors. These 16 items are loaded into 4 factors. Okay, right. Now, if you are looking at the last one, we started with the easiest one. Now, if you can see the performance, 4 factors of the performance, that means P2 to P5 are loaded into 1 factors without having any difficulties or any issues. It's loaded into 4 factors. Okay. Now, you can also see none of the loading items are below 0.3. All are absolute value are more than 0.3. That's why I put that command. Please remove all the factor loadings below 0.3. Otherwise, you are getting mess. Okay. So it is better to have this kind of clean screen. Then now you can see these 4 performance items are loaded into 1 factor without having any issues. But now you can see this performance item 1 is loaded into another factor which is having highest factor loading. So what does it mean? It means that this performance item number 1 does not belongs to these 4 factors, 4 indicators. So it's loaded in a separate way, mean the performance item 1 does not measure what we actually measured. Right? So it doesn't belong to our 1 factor. So that means you have to remove that performance item from your, that performance item 1 from your performance factor. Okay. So how to do it? You have to remove that one from the factor analysis. Right? So we have to do this kind of adjustment one by one. First, I am starting from the easiest one. That performance, 4 items are loaded into 1 factor, but only 1 item is loaded into another factor. Therefore, we have to remove that unrelated loading into this specific performance factor. So I'm going to again with the same command, factor analysis. Then I remove performance item 1 from this and press OK again. This is step-by-step process. You cannot do it exactly in a shortcut way. We have to do one by one. So I remove performance 1 item, then I have to run the test again and I press OK. Still we are having the same issue, still loaded into 4 factors, right? Then move into the pattern matrix. Now you can see this performance are loaded into 1 factor, factor number 3. Okay, right. Then we move into the second variable we have, that is our capability. It has 5 items. Now again you can see, it's also 4 items loaded into 1 factor, right? But capability factor 1, that means capability item 1 loaded into another factor. So what does it mean? So it means you have to remove capability 1 item from the capability factor. Okay, so again you have to remove capability 1 and then press OK again. Right, I come into that point again. Still we are having the same issue. Still it's loaded into 4 factors. Right, so look at the pattern matrix. Now performance variable is okay, capability variable is okay, but still we are having some issue. You can see, right, because C2 is loaded again into another factor. C2 loaded again in the another factor. You can see it, right? But all the 4 factors are loaded into one factor, and the C2, this value, that means 0.481 is higher than 0.396, right? Therefore, we keep these things for a moment. I will come to that point later, right? So we can see this item is still in here. Okay, so for a moment, we believe that these 4 items, that means C2, C3, C4, and C5 are loaded into one factor. Right now, it is okay. Now we have another issue with the resources. Right, so resources item number 6, resources item number 5, and item number 3 is loaded into the one factor without having any issue. Okay, but we are having issue with resources 4, resource 3, sorry, resource 2 and resource 1. Now, among these 3 factors, you can see that resource 2 factor highly loaded into another item, another factor. Resource 2 item highly loaded into another factor. So what we can do is we have to remove it. Okay, now I'm going to remove our 2 item from resource factor. Okay, now I remove it and then press OK. Now you can see, now it come into 3 factors loading. Right? Still we might have issue. Yes, we are still having issue. What are the issues? Now this one is okay. This one is okay. Right now you can see that C2 item issue getting solved. Okay, C2 item getting solved. Okay, that's why I told you one step we have to do this process. Right? Now what is the issue? Still resource item 1 loaded into separate factor. Okay, still separate factor, so we have to remove it again. Okay, right, now R1 we have to remove. Right, now again look at this. Now what is the issue? Now what's the issue? Still R4 loaded into 2 factors, and one factor loading, that means factor number 1 loading is higher than factor number 2 loading. So that indicate R4 is also not relevant to this resource item measurements. So unfortunately, we have to remove that R4 items also. Okay. You have to remove it. Now what you can see. Now what you can see. So now you can clearly see. Okay, now you can clearly see all the factor loadings. All the factor loadings are very neatly, all the factors are very neatly loaded into 3 factors. Okay. Now R3, R5, and RC loaded into component 2, that means factor 2. C2, C3, C4, and C5 loaded into factor 1. P2, P3, P4, and P5 loaded into factor number 3. Okay. Now I'm taking you to the main total variance explain. Now you can see all the factors are loaded into 3. All the items are loaded into 3 factors. Okay. Now, let's look at this KMO value. I told you I will come to that point later. Now here, the factor analysis conditions. Okay, factor analysis conditions. What are the conditions? First of all, we want to make sure that items are loaded into the given factors. Right now, that condition is okay because we have 3 variables. Now, 16 items loaded into 3 factors, and then we have to remove some item from that. This is why I told you when you are preparing your questionnaires, at least you need to have 5 measurement items for one variable. Now you can see we have to remove several items from the factors. Right now, suppose that you have only 3 factors. Suppose that you have only 3 indicators for measuring variable. Now, if you have to remove 2 items, you have only one items to measure. Right? So that means your variable is not valid anymore. That's why I told you at the very beginning, you have to have at least 5 measurement items to measure one variable. Okay. Now, my conditions. Now KMO value, normally, right, these are conditions. You can prove with the some literature also. So this KMO value has to be greater than at least 0.6. At least 0.6, right? Greater than 0.7 is fine, right? It's good, right? 0.7 is fine. 0.6 is also good. And if it is greater than 0.8, that indicate it's better. Okay, it's better. Right, now these are the conditions. So KMO has to be at least 0.6. Right, if it is more than 0.7, perfect, it's fine. And if it is 0.8, it's perfect. Okay, now these are the conditions. And this total variance explained, that means all three factors, that variation of these 11 items or all the measurement items are explain 62.17 variation of your variables. That means it's good. Normally, this total variance explained has to be more than 50%. Okay, it has to be more than 50%. So it is better. We have 62.17, right? And then we already know that this pattern matrix, all the items are loaded into separate three factors, right? Now, item number 1, that means factor 1 representing capabilities, factor 2 representing resources, factor 3 representing your performance. That's the way we have identify those factors, right? Now, these are your factor loadings, right? So that indicate in order to measure the resources, so resource item number 3 weighted by 0.92, item number 5 weighted by 0.878, and item number 6 in the resource weighted by 0.6. Okay. And for capabilities, item number 2 loaded with 0.52 weight. Likewise, performance, item number 2, 3, 4, and 5 loaded with this given weighting. That's why we call them as a factor loadings. We need those value when we are measuring the validity. Right? Now, I believe that you are clear with how to do the factor analysis. Now, remember, factor analysis doesn't indicate that your measurement items are valid. But these factor analysis we required to make sure that your measurement items are valid. Now, let's see how to do it. In order to test the validity, that means first we need to take the component validity, conversion validity, we need these factor loadings. Okay. Now I'm going to show you, I'm taking these values, okay, and now let me share another Excel sheet, right? Now you can see these are your factor loadings, okay, these are your factor loadings, right? Now we are going to measure the conversion validity. We call it as, when the conversion validity we normally call average variance extraction, right? We call average variance extraction, simply we call AVE value. Okay, so AVE value. The standard is that AVE value, that means average variance extraction value, has to be greater than 0.5. Then only we can ensure that your measurement items are valid. Now I'm taking those items. Now resource, we have 3 measurement items, right? Then these are the factor loadings. Now you can see these items and these items are here, right? Same thing. Now I'm taking them. And in order to measure this average variant extraction value, we have to have square root of square value of these items, right? So this factor loading square value we need to have, right? Then I'm taking the square value as 0.921 multiply by 0.921, then you can have this value. Likewise, each and every factor loading, we need to have a square value. Right? Now, for an example, we have to take this 921 multiplied by 921. Okay. Now, this is the square value and we can take it. Right? Then we have to take the summation of this squared value. Right? The summation of this squared value, how to take it? You can take the auto sum, right? And take the value. Now you can see the same figures I am taking in here. Right? And then after taking the summation of squared value, we can make the calculation of AVE. How to take it? You have to take the summation of square value and divided it by number of items. So how many items we have? We have 3 items in resource factor, right? Then divided it by 3. Then you will get the average variance extraction value. Now this is the average variation extraction of resource component. Now what you can see, is it greater than 0.5 or less than 0.5? This greater than 0.5. Then you can ensure that the measurement items of resource factor are valid. Okay, are valid. Likewise, you can do the rest of these items, right? Now for a C2, you can calculate it here, right? So square root value you can take like equal and multiply it by itself. Then you can take the square value, then take it, then get the auto sum. Okay, then this one should be divided by number of items. How many number of items now we have? We have 4 items. So then that's the value. Okay. Now we are having issue with this. Then it is greater than 0.5. It's perfect. Okay, that means 4 measurement items of capability factor are valid. Then we are coming to the P2. Right? Now these are the factor loadings. Now you can see in here. Right? These are the square value of the factor loading. And this is the summation of square value. And it has to be divided by 4. And you will get the average variance extraction of performance factor. Now what you can see, it is less than 0.5, isn't it? It is less than 0.5. Now we are having issue. That is issue because it's not met the standard. It's not met the standard. That means these 4 measurement items still not valid in measuring performance factor. Okay. Then again, we have to go back to the measurement, our factor analysis, and we have to remove the lowest factor loading item from the performance measurements, right? So what you can see, the lowest measurement item is P5, right? So you have to remove it. Unfortunately, we have to remove P5 item from the performance measurement, right? So let's go back to the factor analysis and remove P5 items. Why we remove P5 item? Because its loadings are not adequate to get the average variance extraction. Okay. So again, you can see the P2 factors, right? I'm taking it in here. Right, and paste it. Now take the old value, right? All the values I'm taking again. That's why I told you this is a step-by-step process. We have to do it several times if adequate standards are not met, right? So I'm calculating again all the factor loading square, then summation, then average variance and extraction. And for a P2 also, I'm taking these values and calculate it. Now you can see, right? Now what you can see, all the values are greater than 0.5. So that means your measurement items are now valid. Okay. Now, how many items for resource factor? There are 3 factors. There are 4 factors for capability factor. sorry, 4 items for capability factor and 3 items for performance factor. Now you can see when we are making the validity test, we have to remove so much of items in your questionnaire. That's why I told you always you need to have adequate measurement items in your questionnaire. Otherwise, you are getting in trouble at the last moment. Right? Okay, so this is the convergent validity. That is first validity test in your measurement items. Right? Then look at the discriminant validity. So how to take the discriminant validity? Discriminant validity we are checking with taking average variance extraction value and correlation matrix, right? So I will tell you how to take the correlation matrix. Okay, now get back to your data set. I'm going back to your data set. And yes, right, now I think you can see it. I'm going back to your data set and again, I will do this factor analysis, right, with the relevant component. Now we have only this loaded item, proper loaded item, right? Now, in order to do the discriminant validity, we need to run correlation analysis, right? In order to do the correlation analysis, we have to take the mean value of those items, right? We can do it very easily if you put this, if you go with this score command. Okay, if you go this score command, right, and tick this save as variables, right, tick this save as variable, and you can see that under the method, the regression is automatically selected, right? When you are tick this save as variable, this regression is automatically selected. Then press continue, then press OK. Okay, then go back to your data set. Okay, go back to your data set, right? Now what you can see, if you go back to with the last rows, now these are your mean values of these measurement items. That means these are the factors, that means compile items of your relevant factor, right? These items, the relevant items, now going to be compiled by the system, right? Then we can identify them as a mean value of your valid measurement item, right? Now its component as factor 1, factor 2, and factor 3. Now you should be brain enough to identify what are those factor 1 and factor 2, right? So based on our pattern matrix, we identify that factor 1 as a capability factor, right? And factor 2 as a resource factor, and factor 3 as our performance factor. Likewise, you have to rename your variables into that way, right? So factor 1 you have to rename as, if you go back to your variable view, factor 1 you have to rename as capability, since I have already made sure that, right? So I cannot rename it. Okay. And then factor 2 you can take it as a resource, and factor 3 you can take it as a performance, right? Now you can see I have already put them in here, the same values. Okay. So I will remove them. Right now, these are the factors I have taken from this scores value. Right now, it is easy. Now we can do the correlation matrix. Right? Go to analyze, get the correlation, go with the bivariate, select it, and go down with your variable and select all these comprise 3 factors. Right? And it should be Pearson and it should be two-tail, and click OK. Okay. Then what you can see, this is the correlation matrix. So I will copy it and come into this component. Okay. Now you can see this is the correlation matrix. right? I'm taking those values in here, right? This is a correlation matrix, and this is the way we are calculating average variance extraction last time, right? Now you can see, okay? So taking all the things, and then this is the discriminant validity, and I'm taking the first one, right? So here you can see that the correlation between resources to capability. Resources to capability is here, right? It's 0.39, so round it as 0.4. Okay. And the performance with resources. Performance with resources, it is minus something, minus 0.01 something. Sorry. Yes, positive 0.01. So I put it in like this. Right? Then performance into capability, Okay, performance into, where is it? Yes, performance, resources into capability. So you have to find it in here like this, resources into performance, right? Likewise, you have to take the values, in here. Okay, resources into performance, so minus 0.7. And capability into resources, where is it? Capability into resources, yes, it is 0.3 something. I think we have already checked it, right? Likewise, you have to put the matrix like this. And from this bold mark, what are those values? I already make it in here. That is the square root of average variance extraction, right? If you go back to this is your average variance extractions of resources, capability, and performance. If I'm taking this in here, right? Sorry. This has to be taken as values. Okay, now this is the average variance extraction of resources and capability and performance. Okay. And so then the square root of this, you have to take it as like equal square root of this. Now you can see these are the values, right? Likewise, you can take the values of those, right? So those square root of average variance extraction has to be greater than the correlation value of each variable with other variable. Right? Now you can see. So 0.81 is greater than 0.4 and 0.01. 0.79 is greater than these all values. Likewise, this average variance extraction square root value has to be greater than each correlation component of one variable with the another. Right? This is the way we are measuring discriminant validity. This is the way we are measuring discriminant validity. Now, I believe that you are okay with how to measure average variance extraction and discriminant validity. So average variance extraction, you have to take all the factor loadings, take the square root, take the summation, and divided it by the given number of items. So those AVE value has to be greater than 0.5. Now we identify we have issue within here, then we calculate again factor loading after removing this lowest loading item, right? Then you can come up with all the AVE values greater than 0.5. Then discriminant validity, you have to take the correlation matrix, right? How we take the correlation matrix, right? So it's very simple, right? Go to that factor analysis, and under that you have to get the score. Then tick the save as variable and press continue, right? Then you will get with, I'm not going to press it again because I have already calculated it, right? So then you will get the complex factors items in each factor, right? Then name it according to the factor loadings, right? Then go to analyze, go to correlation, bivariate, select your three factors and press OK. Okay, then you get the component validity, and then you have to calculate square root of AVE and take the correlation values in here like this, right? And here like this, and 0.1, I think it's here. Okay, so likewise you have to take the matrix. So you have to take it manually because there is no any other automation method to make it. Okay, so then make sure that all the square root of AVE greater than your correlation among each variables. Right, now you can see this is greater than, this value is greater than this 2, this value is greater than this 1, this value is greater than this 2, this value is again greater than this 1. Okay, now this is the way you have to measure the validity test. Right, so then after measuring all the validity and reliability, right, then you can run the, validity test, then you can run the reliability. Okay, how to do it? Go to analyze, then scale. Okay, then select it, then select only the valid item. Right, now you don't need to select all the 6 items because we know that some items we already removed. Right, then select only valid item. I'm not sure what are the valid items here. Yes, here. R3, R5, and R6. Okay, so for a reliability, you have to check the factors, items of each factor separately. First, I'm checking the reliability of resource factor. Right, we have only 3 items. Then press OK. Now you can see the Combridge alpha value is 0.754. So Comba value, we know that normally it should be greater than 7. Now the reliability of the resource items are 5. That means 3 resource items are reliable. Likewise, you can check the others also. Right, then we check the capabilities. You can remove these 3. And then capability, we have C2, C3, C4, and C5. We have 4 items, then check OK. Now you can see Combridge alpha value is 0.815. It is greater than 0.7. Likewise, we can do the last one, performance. I think we have only 3 items. Yes, P2, P3, and P4. Okay, and check it. So you can come across that its Combridge alpha value is 0.548. So we have some issue. Yes, we are having some issue because it's not reliable. It's not reliable, but in some cases, literature accept that if the items are valid, and if the reliability is not that much, met the standard, that means it is 0.5. Okay, but still we can move with our final analysis because items are valid. Right? And Combridge alpha value is somewhat greater than 0.5. In that manner, we can move forward with our main analysis. Right? But this is still not good measurement, but unfortunately, we cannot remove anything because we have only 3 items for this factor. Right? Therefore, since Cromba value is greater than 5 and the validity is also validity standards are met, so then we can proceed with the further analysis, right? But you have to justify your reason with the valid literature. That's very important. You have to justify the reason with valid literature. So this is the way we are going. We need to measure the validity, right? So we perform factor analysis, that is we call confirmatory factor analysis. Based on the factor analysis factor loadings value, we test convergent validity. That's why we calculate average variance extraction. And then we test the discriminant validity based on the correlation matrix. And finally, we test with the reliability test and make sure that your data set is valid and reliable. Okay. Then we will move with the regression analysis or your main analysis. And one thing before I forget, now this is a way you can present your data into a chapter 4 or your data analysis chapter, right? Like here, this is your factor, that means your variable, and this is the KMO value and Bartle test value, and this is the way you can find the Bartle test value. And let's see here, you can see the Bartle test value in here, right? And its significant value also there, right? So that's the way you need to present your data, because it is very important how you are presenting, right? Now, these are the total variance explained. So presenting data is very important, as I mentioned you. So the total variance explain, and then average variance extraction, that is your calculation, and the factor loadings. So you can easily take it from your SPSS output. So this is the way you can present, and this is your reliability test presentation, right? Combine alpha value based on standard item, then number of items. Likewise, you can make the presentation like this. Okay, right. Now let's move into the regression analysis.